In the group list, we are on number 8. So the binary number for 4-bit binary is 100, meanwhile for the 5-bit is 01000. So for task 1, we need to build a 4-bit circuit and a circuit according to the page 15 in the lab manual. For the first circuit, I choose a NAND gate and an OR gate, 4 on-off toggles as the inputs and an LED as the output. The inputs are labeled as A, B, C, and D respectively, meanwhile the output is labeled as E. Firstly, we connect input A and B to the NAND gate. The output from NAND gate then connected to the OR gate as an input. As you can see, the output from NAND gate is 1. Let's finish connecting all our inputs first, input C and D to the OR gate. And as you can see, the LED is lit up, which means it is in high state even when all inputs are low. It is because NAND gate behavior. NAND gate will only produce low output when all inputs are high. However, since our group binary number is 1000, the input A is set to 1. NAND gate receives 1 as the output. Hence, the output E is 1. Moving on to the next circuit. So, the task instructed us to construct a circuit per manual at page 15. According to page 15, we need an AND gate and an OR gate. Then, we need the input. I choose toggle switch as the inputs, and it's 5 of them. Then, we label the inputs as A, B, C, D, and E. We are gonna need the output as well. So, I choose LED as the output and label it as F. Then, we connect the input A, B, C to the AND gate. Meanwhile, the output from AND gate we connect to the OR gate as input. We also connect the input DE to the OR gate. The final output will be the result to output F.
For task 2, each group must draw and construct the assigned logic gate on a breadboard with the output F connected to a resistor and an LED. The objective of this task is to develop basic breadboarding skills. We are from group 8 and the gate we are assigned to construct is an OR gate. The website used to build this virtual circuit is called Tinkercad. To construct the OR gate, we need one breadboard, 174HC32IC, also known as a quad 2-input OR gate, one LED, 1 kilo ohm resistor, 2 slide switches, and one 5-volt DC power supply. First, connect the positive terminal of the power supply to the positive rail on the breadboard and the negative terminal to the ground rail. Place the 74HC32IC across the center divider of the breadboard so that each pin is accessible. Connect pin 14 VCC of the IC to the positive rail. Connect pin 7 GND of the IC to the ground rail. Next, place 2 slide switches on the breadboard. For each switch, connect terminal 1 to the ground and terminal 2 to the positive rail. The common for switch A is connected to input 1A of the IC, whereas the common for switch B is connected to input 1B. For the output, connect the anode of the LED to output 1 of the IC. As for the cathode, it is connected to one side of the 1 kilo ohm resistor, hence the resistor is placed here. In a logic OR gate, the output is high if at least one input is high and the output is low only when all inputs are low. Now, let's test the circuit. Right now, both switches are off, which is logic low, the outputs remains low and the LED stays off. But when either or both switches are turned on, which is logic high, the output of the OR gate will go high, lighting up the LED.
Task 3 requires us to draw the breadboard for the circuit on page 12 in manual. Before we go to the constructed circuit, let me show you the equipment needed for the circuit. We need a breadboard, an LED, a switch, 5 resistors. The resistor is needed because when a switch is open, the input pin is floating. It could randomly read high or low. So a resistor makes the pin to read low or 0 when the switch is open. Then we need the 7408 IC and 7432 IC, and lastly a power supply. The circuit is built per the manual at page 12 where switch 1 and 2 are connected to IC 7408 at pin 1 and 2 to make them as input A and B respectively. Then switch 3 is connected to IC 7432 at pin 2 as an input C. The pin 3 on IC7408 is connected to pin 1 on IC7432 as an input. The output from IC7432 is connected to the LED as an input. The pin 14 and 7 of both ICs are connected to power supply and ground respectively. The results are shown through the LED. This is the truth table obtained from the circuit. When input ABC is 0, 0, 0, the output D is 0. When the input is 0, 1, 0, the output is 0. When the input is 1, 0, 0, the output is 0. And when the input is 1, 1, 0, the output is 1. When the input is 0, 0, 1, the output is 1. When the input is 0, 1, 1, the output is 1. When input is 101, the output is 1. And lastly, when the input is 111, the output is 1.
Task 4, all groups must prepare the breadboard circuit of a 7-segment display, and our group, which is group 8, must display the number 7. The component needed to do this task are one breadboard, one 7-segment display, one resistor, 7 slide switches, and a 9-volt battery. Firstly, insert the 7-segment display. Connect the common cathode pins to ground. Place 7 slide switches on the breadboard. For each switch, connect one side to the positive rail, which will be powered by the 9-volt battery through a current limiting resistor. Next, connect the other side of each slide switch to a segment pin on the display. After that, place a resistor between the positive rail and the battery positive terminal to limit current to the segment and protect the LEDs inside the display. Lastly, connect the power supply, which is a battery. Connect the red wire from the clip to the positive rail on the breadboard and connect the black wire to the negative rail. Now, let's test the circuit. We need to light up number 7, hence switch on the alphabet A, B, and C, and here is the result. The number 7 is displayed.